Okay, fine. So, yeah. So, this is your yesterday's class. Okay. We have discussed basically derivation and those things. Huh? So,
Okay, sir.
you just check the recording, chemical thermodynamics. We have started from here and then we have done this Euler's reciprocity rule. So, what is your Euler's reciprocity rule? So, you know derivation, right? So suppose z is a function of your x and y. Okay, z is a function of your x and y. So if I do differentiation of z with respect to x, okay, that time y is constant. If I am writing like that, so that means y is your constant. Okay, so del z by del x at constant y, and whatever the value you are getting here, that we will derive with respect to y. So what we are doing, del y of del z by del x at constant y, and overall your constant is x. Okay, so we have proved these things. You just go through the video, then only you will understand. And if this condition and if it follows this condition, okay, this del y by del z by del x at constant y at constant x is equal to what, del x by del z by del y at constant x, and overall constant is y. That time we can say that z is an what, z is an exact differential. Okay, z is an exact differential. Okay, so today we will start after that. So for ideal gas equation, for van der Waals gas equation, we have discussed yesterday. Just go through the video. Otherwise you cannot understand.
Okay, sir.
Okay, so today we will start. Write down total differential. Total differential. Okay, so similarly, suppose z is a function of x and y. Okay, so z is a function of x and y. Now that thing, what I can write down, so dz is equal to, okay, we can write down that del z by del x. So that means we are differentiating z with respect to x, and when we are differentiating with respect to x, that time that other variable will be constant. So here y is constant. Okay, into what, into dx, plus what, plus I can write down del z by del y. Okay, now I am differentiating with respect to y, so that means the other variable will be constant, into what, into dy. Okay, so this is the thing. So total differentiation means you have to represent like this. Okay, you have to represent like that. dz is equal to what, del z by del x at constant y into dx, plus what, del z by del y at constant x into dy. Now see, this dx will cancel out, dy will cancel out. So you have to remember like that. Now write down that let z is an exact differential. Z is an exact differential. Okay, so suppose Z is an exact differential. So according to that formula, what we can write down, that del Z by del X. Okay, so when y is constant, now that thing we have to derivation, sorry, we have to differentiation with respect to y, del y, when your overall constant is x, is equal to what, is equal to your del z by del y. Okay, del z by del y, that time constant is your x, and what is the other thing, del x, that time the overall constant will be y. So this condition they have to follow. Okay, now suppose this del z by del x and constant y, that thing I am assuming this is equal to m. Okay, this whole thing is equal to m. So what I can write down, m into dx, and this del z by del y at constant x, that thing I am assuming n. So that means what I can write down, n into dy. Similarly here also what I can put, so this del z by del x at constant y, that thing I can put m, right? So what I will get, I will get del m by del y
Del y.
is equal to what, del z by del y at constant x, that thing I am assuming n. So that means I
N.
can write down del n by del x,
Del y. Del x.
right?
Yes, sir.
And what are the constant we have? So here see, constant is your x and
y.
here the constant is your y. Okay, fine. So basically
Yes,
if they are mentioning that z is an exact differential or some function, they will give you that find out this is an exact differential, so you have to use this equation. Okay, fine. You just check yesterday's class, you will get an idea. Okay, okay. And next another important thing, so that is called your cyclic rule. Okay, cyclic rule. So cyclic rule, so suppose x we have, okay, so x is a function of what, x is a function of y comma z. Okay, x is a function of y comma z. Now see, very simple. So what is the cyclic rule? Del x by del y. See, I have written x and y, so what will be the constant? The remaining one, z. Next will be what? Del y by del z. I have written yz, what will be the constant? X. Next will be your what? Del z by del x. So I have written z and x, what will be the constant? The remaining y, right? And that will be is equal to minus 1. Okay, now how to do this? So first of all write down like this. Suppose I have x, then I have y, then I have z. So come like this, in clockwise come like this, from x to y, then y to z. So see, first of all to x to y, right? So del x by del y. So I am coming like this, x to y, so that's why del x by del y. Next is what? Y to z, so that's why del y by del z. Next is what? Z to x, so that's why del z by del x. Okay, fine.
Yes, sir.
So this is your cyclic rule. Okay, and if you do the product of these all the derivations, then you will get minus 1.
Yes, sir.
Fine, okay. Okay, just a minute, huh? Fine. So next write down some applications. Okay, some applications. Okay, so write down the question first of all, that the exact differential, the exact differential, okay, of state function okay, what is your state function? Function of x comma y, okay, among the following is what? So the exact differential of state function of x y among the following is what? So first of all I am writing, suppose you have this x into dy, okay, x into dy. So exact differential means what? Exact differential means this formula. Okay, exact differential means this formula, del z by this formula, del z by del x at constant y. Okay, then you have to do with respect to dy. Okay, And if I am mentioning here this total differential, so you can do like this, that suppose you have a z, okay, z is a function of x and y, so dz is equal to what, del z by del x at constant y into dx plus del z by del y at constant x into dy. Okay, so here they are asking that you have an exact differential of state function, what, state function, sorry, exact differential, write down exact differential df, okay, exact differential df of state function f of xy, okay, among the following. So suppose I have x into dy, so that thing I can write down like what. So first of all, see, I can write down that df, they have clearly mentioned it is function of your x and y, right? So I have to write down like this, that del f by del x, what will be the constant? Constant is the remaining y, okay, into dx plus what, del f, what remains now, we have done with x, so I have to now do with the y.
Y.
And if I am doing derivation with respect to y, so constant will be what, x into what, dy. Okay, so first of all, arrange this thing like this, so I can write down x into dy plus what, nothing is there, so I can write down what, 0 into dx, right? If I multiply anything with a 0, that will be 0 only, right? Right?
Yes, sir.
Now see what to do. Now you have to do like this, so basically we will interchange now, okay, we will interchange. So this x, okay, this x, we will derive this x with respect to x dx, and we will derive this, we will differentiate this 0 with respect to dy. So I have to write down like this, del x by del x, okay, del x by del x at constant y, and here it will be what, del left right hand side I have 0, so del 0 by what, del y at constant x. Now this del x by del x, that one we are getting what, 1 only, and if you do derivation of 0, so that what you will get, 0. So that means what, 1 is not equal to 0, so this is not an exact differential. Okay, if you are getting the same value, then only we can say this is an exact differential, otherwise not. Clear how to do?
Yes, sir.
So basically left hand side is equal to right hand side, that you have to do. Okay, one more thing I am giving. So suppose number B I am giving you this, dx minus what, minus x by y into dy. Okay, they have given this, so try to do this. So first of all interchange them, okay, interchange them. So that means this side I have nothing, right? So nothing means what, I have, it is multiplied by 1 only, right? If nothing is there, so that means it is multiplied by 1. So now interchange, so y will come this side, x will come this side. So what I can write down, that del of 1 divided by what, del y,
Del Y.
right? What will be the constant? Constant will be your x, and dx is coming into this side, so it will be what, minus is there, so minus I am keeping. Now what, del of, I can write down like this, del x of what, x by y, right? X by y, what is constant?
Y.
Y. Okay, now again if you do derivation of some constant, I told yesterday also, derivation you have done in class 11 12, even in graduation also. Suppose ddx of 5, okay, so if I do derivation of any constant value, always I will get 0. So 1 is a constant, so that means this value you will get 0 only. Okay, and here y is constant, see, y is constant, so 1 by y will come out of the bracket. Okay, so is equal to what I will get, minus 1 by y, then what I am getting, del x by del x, right? Or ddx of x, that will be what, only 1. So again this 0 is not equal to what, minus 1 by y, right?
Yes, sir.
So again it is your not exact differential. Okay.
Okay, sir.
Now this thing you just try by yourself. Okay, y into dx minus x into dy. This one you just try by yourself. Done. Done. So what do we have to do? So dy will come in this side and dx will come in this side. So write down what I will get. Del y dy by dy at constant x
X
is equal to
is
what?
equal to minus del x
Hmm.
by del x
Hmm.
constant y.
Yeah. So this cancel, this cancels. What I am getting? 1 is equal to
1 is equal
minus
to
1. So
1
again this is
minus
not equal, right?
yes sir.
So that means this is also your not exact differential. Okay.
Yes sir.
Okay, another one. Try this one, then I will understand you understood this. Okay. So 1 by y dx minus x by y square into dy. Try this one. Then tell me what you are getting.
This also not equal to what sir?
What you have to do? So first of all, interchange them. So
Interchange
what I will get? Del y of
y
what? 1 by y, right, is equal to, okay, what is the constant?
x
X. This right hand side I have minus, then what? Del x
x
of what?
by
Sorry,
1
yeah,
1 by
x,
x.
no, x is there, no? X by y
Okay, x
square.
by y square.
X by y square, what is the constant?
Y.
Y. Fine. Now see. So I told you, told yesterday that suppose you have this ddx of what? 1 by x. What will be the value? In mathematics you have done this kind of thing. Okay, so that thing I can write down ddx of what? X to the power minus 1. Now we have a formula ddx of what? ddx of x to the power n. So that will be what? N into x to the power n minus 1. So what is the power you are getting? So we will get that power minus 1 into x. So that means x to the power n minus 1. So it will be now minus 1 minus 1. So we are getting minus 1 into x to the power minus 2. I can write down minus 1 by x square. So similarly here dy of 1 by y, that you will get minus 1 by y square. Okay. Now check in the right hand side. So constant is y is constant. So this y square term will come out of the bracket. Okay, out of the bracket. So what I am getting? Minus 1 by y square. And what left now? So this thing left, del x by del x at constant y. So this will cancel, we are getting only 1. So see, now we are getting equal in the both side, right?
Okay, sir.
So therefore it is your exact differential. Okay, this is your exact differential. Okay, you just check yesterday's video, some formulas are there. Okay, the
Okay,
basic
sir.
formulas for derivation, okay, differentiation, that you have to know.
Okay, sir.
Fine. Okay, now uh, giving a question, huh? So ideal gas equation you know, right?
Yes, sir.
So write down for 1 mole 1 mole of an ideal gas. Okay, 1 mole of an ideal gas. This equation they have provided. Okay, del P by del T, del P by del T at constant V. Okay, then you have del V by del T, del V by del T at constant P, and next we have del V by del P at constant T. So is equal to what they are asking. Okay, so they have given you 4 options: minus 1, option B, plus 1, option C, minus r square by p square, and option D, r square by p square. Okay, try to do this. So first of all write down the ideal gas equation, then you have to do. Okay, I am helping. So what is your ideal gas equation?
PV is equal to
PV is equal
nRT.
nRT, but here they have mentioned 1 mole, so
1 mole
PV is equal to RT,
RT.
right? So P is equal to what? P is equal to, I can write down RT by V, right? Now see what they are doing, del P by del T. So that means you are differentiating P with respect to temperature at constant volume. So volume is constant, R is your universal gas constant. So find out the value. Similarly, you just find out V is equal to what, then do derivation with respect to T and P, and then you multiply, you will get it. Okay, clear how to do? Try it.
Okay, sir. option C, yes, sir.
Option C you are getting?
Yes.
Very good. Option C is the correct answer.
Okay, sir.
So basically what we have to do, del P by del T, right, at constant V. So that means if I do, so what I have to do, del T, what is the P value? RT by V, right? So put the value here, RT by V. So they have clearly mentioned that volume is constant. So volume is constant as well as this R is also constant. So this R by V will come out. Then what I am doing, del T by del T. So which one is cancelling out? So I am getting R by V from here only. Okay, next you have to find out the volume. So PV is equal to what? RT. So V is equal to what? V is equal to RT by P. So now you have to do what? Del V by, first of all I am doing this, del V by del T at constant P. So pressure is constant. So first of all write down, put the value, del T, put the V value. What I have? RT by P. So R is constant and P is also constant. So R by P will come out. Then what I have? Del T by del T. So again it is cancelling. So finally we are getting R by P only. Third one, what do we have? Del V by del P. Okay, del V by del P at constant T. So that means del P of what? Of RT by P, right? RT by P. So here temperature is constant and R is also constant. So RT will come out. Then what I have? Del P of what? 1 by P. So what will be the value of this del P of 1 by P? ddx of 1 by x. What will be the value? Just we have done a few minutes back this thing, ddx of 1 by x. What will be the value? Minus 1 by x square.
Minus 1 by x square.
So here it will be del P of 1 by P. So that means it will be what? Minus 1 by P square. So if I multiply them, so if I multiply, what I will get? So see, they are asking this. So now tell me the value quickly. So del P by del T, what is the value you are getting? For del P by del T, R by V, right?
Yes,
this
sir.
value I am getting R by V. Next dV by dt. dV by dt is what? R by P. So here I am putting R by P. And the last one is what? Last one is your minus RT by
P square.
Yeah, minus RT by P square. So put the value minus RT by P square, right? Now what to do? So you are getting this, na? So I am writing minus what? We are getting here, we have R square into RT divided by what? We have PV into P square. Now from ideal gas equation, what we know? PV is equal to RT, right?
Yes, sir.
Right, this thing we know.
Yes, sir.
So here we can put that, suppose minus R square into RT, and PV is equal to what? Also RT. So it will be RT into what? P square. This cancels out. What we are getting? Minus R square by P square. Okay?
Yes, sir.
Okay, very good. Now write down another question. So for thermodynamics, basically we will do question answer in the class only, huh? Okay, so write down, for internal pressure, so what is your internal pressure? Pi T. Okay, so pi T is equal to what? T into del P by del T at constant B minus P. So this is the equation they have provided you. Okay, This is the equation they have provided you. Now they are asking for 1 mole of van der Waals gas. 1 mole of van der Waals gas is what? Okay, so they are giving you options: A by V square, option B they have given this A by V square into RT divided by what? B minus B. Option C they have given 0, and option D is your RT by B minus B. So they are asking this. So they have given you an equation. Pi t internal pressure is represented by pi t. What is the equation they have given? T into dP by dt at constant B minus P. So they are asking for 1 mole of van der Waals gas. What will be this internal pressure value? Okay. So basically, first of all, you have to know what is your van der Waals equation. What is your van der Waals equation for 1 mole? So in general, the van der Waals equation is this: P plus A n square by V square into V minus NV is equal to nRT. For 1 mole, it will be what? For 1 mole, it will be P plus A by V square into what? B minus B is equal to RT. So find out the P value from here. So how to find out? I can write down like this: P plus A by V square is equal to what? RT by V minus B, right? So basically P is equal to what we are getting? P is equal to RT by B minus B minus what? A by B square. So this is the pressure value we are getting, right? This is the pressure value we are getting. Now see what in the equation they have given: what? Del P by del T at constant B. So that means you have to do derivation with respect to, you have to do differentiation with respect to temperature. Okay, so find out this value: del P by del T at constant V. Volume is constant, keep in mind. Now do the derivation with respect to temperature. Tell me what you are getting. Check it, what you are getting.
Yes, sir. Is sir A by V square?
Are you sure? So del P by del T at constant V, na?
Yes,
so that
sir.
means I have to do differentiation with respect to temperature, right? So
Yes,
first
sir.
of all, put the value of pressure. What I have? So I can write down like this, that del t of what? Del t. So what is the thing we have? RT by v minus b minus what? A by v square. What is the constant? Volume is constant.
Volume.
So now see, I can separate it. So what I am getting if I separate? So I can write down like this, del t of what? RT by v minus b at constant volume, right? At constant
Yes, sir.
volume minus what? Del t of a by v square, okay, again at constant volume. Now tell me, volume is constant, right?
Yes, sir.
So if volume is constant, this term is constant, this v minus b, so that will come out of the bracket, right?
Yes, sir.
So 1 by b minus b into what I have, this r is also constant, na? This r is also constant, this is your universal gas constant,
Yes.
right? So that will also come out of the bracket. Whatever the constants you have, that will come out of the bracket. Then what I have? Then I have del t by del t at constant v. So this you are getting 1 only. Now for the second one, see, volume is constant here, right?
Yes, sir.
A is constant, okay? A is your van der Waals gas constant, B is also your van der Waals gas constant. So these two things are constant. So A is constant, B is also constant, because we are mentioning that,
Yes,
right?
sir.
So if you do derivation of some constant, what you will get? If you do
A by v square.
no, A by v square, this is a constant value. So what I am asking, suppose you are doing this del x of 5. So if I am do differentiation 0, so same here also. If volume is constant, volume is not changing. If it is not changing, if it is constant, so if you do differentiation of any constant, always you will get 0. Okay.
Okay, sir.
So what is the thing we are getting? We are getting r divided by what? R divided by v minus b. That is what? That is the value of this del p by del t at constant v. Okay. Now
Yes, sir.
put the value here. See, what do we have? We have this equation, right? So put the value. What do we got? T into, what is the value you are getting? R divided by what? B minus B minus what? P, right?
Yes, sir.
I can write down like this. I am just putting the value here, okay? Nothing else I am doing. So what I am getting? RT by V minus B, right?
Yes, sir.
So RT by V minus B is equal to what? Check. This is your number 1 equation. RT by V minus B is equal to what?
P plus A
by V square. So I can put here, right? So if I put the value, what I am getting? P plus A by V square minus P. So this pressure cancelling out. What we are getting? A by V square. Okay. So
Yes, sir.
which option? Option A. Clear how to do?
Yes,
So in
sir.
thermodynamics, you have to know the differentiation, okay? Differentiation and this what? Integration, those things, basic things you have to know. Okay,
Yes, sir.
fine.
Yes, sir.
Okay. Fine. Okay. Now, next question they are asking, for an ideal gas. For an ideal gas, so del P by del T at constant V is equal to what we have? Del T by del V at constant P is equal to what we have? Del V by del P at constant T. Okay, that they are asking equal to what? Equal to what? So option A they have given 0, option B they have given -1, option C they have given 1, and option D they have given 2. So what do we will get here? So I discussed cyclic rule, right? See, what is cyclic rule? This one, cyclic rule. So if x is a function of your y and z, then suppose x to y, y to z, z to x, we are moving, right? So basically what, del x by del y at constant z into what, del y by del z at constant x, and del z by del x at constant y will be what, equal to -1. So similarly here, this pressure, here they are asking this thing, na? So this thing, okay, so this pressure is what, this is a function of your volume and temperature, okay. If you increase the volume, pressure will decrease, okay. If you increase the temperature, pressure will increase. So pressure actually depends on your volume and temperature. So basically we can write down, we can apply. So I am writing like this, P V T. So first of all we are moving to P to V, so I can write down del P by del V, okay, del P by del V at what, at constant temperature. Then we are moving to volume to temperature, so it will be what, del V by del T at constant pressure. Next we are moving to what, temperature to pressure. So what I am getting, del T by del P at constant volume, okay, right? So see, all things are cancelling out, and that by cyclic rule, what is the value, -1, okay. So if we apply here cyclic rule, you will get the value -1 only. Fine?
Yes, sir.
Okay, fine. So that's it, okay. Now write down next that thermodynamics basic concepts, okay, basic concepts, okay. So we have two kinds of property. One is your intensive property, okay, and another one is called extensive property, okay. So intensive means what? So intensive means it is independent, okay. Write down, independent of what, of amount or what, quantity of matter, amount of or quantity of matter, okay. Extensive means what? Extensive will depend, okay. So it depends upon the quantity, depends upon the quantity or amount of matter, Now see how to remember. Basically exam time we forgot, so how to remember? See, intensive we have I, in independent also we have I, right? So intensive will be always independent, I, okay. Extensive will be opposite, dependent. Clear?
Yes, sir. Yes, sir.
So if I write down some example, so for example, okay, I am giving one example. So suppose you have a room, okay, right? This is your home, okay. Suppose this is your home. So basically, if you are staying in your home, so it has a temperature, right? No, room temperature 25 degrees centigrade. Pressure will be what? Pressure is your atmospheric pressure, 1 bar, right? And volume, okay, of your if you are staying in home, so that has some volume, right? Suppose you are staying in some 2 BHK or 3 BHK flat, so it has a specific volume, na? Right? Now suppose I am dividing the home into 2 rooms. So suppose you are studying here and your parents are here, okay. Now tell me, which parameter will change in this temperature, pressure and volume?
Volume?
Volume will change. So
Yes, sir.
basically if I divide it into two compartments, so now the volume is becoming V by 2 for this half and V by 2 for
V by
this
2.
half. Temperature and
Yes, sir.
pressure will change?
No, sir. Constant.
No, right? Because we did not feel different temperature in different rooms in our home, right? So
Yes,
temperature
sir.
and pressure will not change. If they are not changing, so that means what? They are intensive or extensive?
Intensive.
Intensive. And whatever is changing, that is what? That is your extensive.
Extensive.
Okay,
Okay, sir.
so that is the thing. So write down some example. So in example you can write down in independent temperature. Okay, next is your pressure. Okay, concentration. Okay, concentration. Okay, melting point. Okay, boiling point. These all are your intensive property. Okay, melting point, boiling point. Fine.
Yes,
Now
sir.
write down some examples of your extensive property. So I already told you one example, that is your volume, right? Just a minute. So just a minute.
Yes, sir.
So I already told, for example, volume is one example. Okay, apart from volume, what do we have? You can write down. Okay, mass is the thing. Okay, just a minute, this writing pad is actually doing some problem. So volume, okay, apart from volume, mass is also your what? Extensive property. And steadily we will do all other things also. For now just remember these two things only. Okay,
Yes,
volume,
sir.
mass. Suppose you have energy. Okay, energy is also your extensive property, and apart from that all the thermodynamic properties that we have not discussed yet. So these are all your extensive property. Okay, enthalpy. Okay, entropy, enthalpy, entropy. Okay, heat capacity. Okay, heat capacity. These all are your what? Extensive property. Okay, Gibbs free energy. This energy is actually known as your Gibbs free energy. We denote it by capital G. Okay, internal energy, that is represented by capital U. So these all are basically our extensive properties. So what you have to remember, all the thermodynamic properties are extensive in nature. Okay, fine.
Yes, sir.
Hmm. Okay, uh, one point write down here, that if if amount of substance amount of substance amount of substance is fixed. Okay, amount of substance is fixed. Okay, so for example, suppose I am asking 1 mole, okay, or 1 gram. So amount of substance is fixed. Okay, so they will be what? Always intensive. Okay, always intensive. Fine. So for example, write down molar volume. So molar volume I already mentioned. Molar volume is your 22.4 liter. Okay, so that is a fixed amount. Okay, or specific heat. Okay, specific heat. Here the heat amount is fixed. Okay, specific heat. Specific heat capacity. Huh? Specific heat capacity. And molar enthalpy. Molar enthalpy. So if the amount is fixed, that time we will consider it as your intensive property. Okay,
Yes, sir.
fine. Okay, another one, write down that ratio of two extensive property, okay, become intensive. Okay, so if you see here, see this mass volume, they are what? They are extensive property, right? This mass volume, they are extensive property, right? So if I writing this mass ratio means what? This thing na, mass divided by volume, that is what? That is your density, right? Density is equal to what? Mass by volume na. So mass and volume, they individually they are extensive in nature, but this density will be what? Density is your intensive property. Okay, so you can add here one more thing, that is your density. Okay, clear?
Yes, sir. Yes, sir.
Fine. So these are the differences between your intensive property and extensive property. Okay.
Yes, sir.
Okay, next, write down state function. So function, already you know what is function, right? But what is state function? Mathematics, you know na what is function, right? Property whose value depends on some parameters, right? So suppose f is a function of x and y. So similarly here also state function means what? So write down that property whose value depends on only initial and final state of the system. Initial and final state of the system. Okay, of the system. So property whose value depends only on the initial and final state of the system. Okay, and state functions. So second point, write down these state functions, they are exact differentials. Okay, exact differential, and if they are exact differential, so what? They will follow which rule? So write down follow Euler's. Yesterday we have done this. Okay, Euler's reciprocity rule. I will show you Euler's reciprocity rule. Okay, so all the state functions are basically they are exact differentials. Okay, and the third point, that cyclic integral. So if you do cyclic integration, okay, cyclic integral of state function is what? Is 0. Cyclic integral of state function is 0. Fine. So what is your this exact differential? I showed you Euler's reciprocity rule, that thing only. Okay, yesterday we have done this thing, Euler's reciprocity rule. Yesterday we have done. So if z is a function of x and y, this equation, okay, it will follow this equation, and if it follows this equation, I told you z is an exact differential. So that means whatever the state functions we have, they will maintain these three properties. Okay, so first thing is what, their value depends only on the initial and final state of the system. They are exactly differential. They will follow your Euler's reciprocity rule, and they are what, cyclic. Their cyclic integral of state function will be what, 0. Okay, so suppose cyclic integration means what, state function. So suppose a is the state, and b is the state. So a is your initial state, b is your final state. So suppose it is moving from a to b, okay, then it is again coming from b to a, okay, b to a, fine.
Yes, sir.
So if I do this na, close integration of dz, close integration of dz, so that is actually divided into two parts. So first of all you have to do this integration of dz, and what is the limits. So here the limit will be your a to b, okay, plus what, plus I can write down integration of dz. Here the limit, so a to b, then it is coming from b to a, right? So here the limits will be what, b to a, okay. Now if you change the limits na, suppose I am reversing the limit, so that time what it will be, suppose dz, integration of dz, here the limit is a to b. If I want to do here a to b only, that time the sign will also change, so it will be minus integration of what, integration of a to b dz. So if you change the limits, the sign will also change, and if the sign is changing, so this thing and this thing is cancelling out, you are getting what, you are getting 0 only, okay. That is the reason they are saying that cyclic integral of state function will be always 0, okay.
Okay, sir.
Fine. Now write down in example that all thermodynamic variable, state thermodynamic variable are what, are state functions, okay, are state functions. So all thermodynamic variables are what, state functions. So for example, what are the examples we have? This is your internal energy, okay. Enthalpy is represented by H, entropy is represented by S, Gibbs free energy is represented by G, and Helmholtz energy is represented by A. So that you will know later, but keep in mind all the thermodynamic variables or properties what we have, these are actually state functions, okay. So Gibbs free energy, enthalpy, internal energy, enthalpy, entropy, Gibbs free energy, and Helmholtz energy, okay. These all are your what, state function, okay. And what are the properties of your state function? These three are the properties, okay. So they depend only on the initial and final state of the system. They are exactly differential, and cyclic integral of the state function will be always 0, fine.
Yes, sir.
Okay, now just a minute. Next write down one more thing we have. So that is actually known as your path function, okay, path function. So path function means what? So write down whose value depends on the what, on the path, okay, depends on the path taken. depends on the path taken. Okay, that is your path function. So for example, work done. Okay, work done is represented by W. Okay, heat energy, okay, that is represented by Q. Heat capacity, so we have two kinds of heat capacity, we will do later. Okay, one is your Cp at constant pressure and another is your Cv at constant volume. So these are all are your path functions, so that means they depends on the path. Okay, suppose you are moving from one place to one place, then another place, then again another place, then again another place, so you are moving like that, so that means you are doing work, na? So that time it does not depend on the initial state and final state, it depends on the whole path whatever you are taken. Okay, even for heating also, suppose you are heating some water, right? So it is a continuous process, na? It is a continuous process, heating is a continuous process, you cannot take the initial value and final value, right? Suppose you are cooking something, okay, you are cooking something, so what you have to do, you cannot suppose you have induction, so in induction you have a temperature like 800, okay, 1000, so basically it's a continuous process. Okay, you cannot put the highest temperature at a time, you have to move it gradually. Huh. So same thing, this heat energy, work energy, these are what, this depends on the path. Okay, here these properties are do not depend on your initial state and final state only. Okay, this depends on the entire path whatever you are taking. Fine, so this is your path function. Fine.
Yes, sir.
Okay, okay, so that's it for today, you just read up to that. Okay, and check yesterday's lecture also, then let me know any doubt.
Okay, sir.
Okay, okay, fine. Okay, bye.
Thank you,
Anything
sir.
doubt from today's class?
No, sir.
Just go through yesterday's video, that
Okay,
derivations
sir.
things you will get.
Okay, sir.
Okay, anything any difficulty you are facing on differentiation on derivation, then let me know.
Okay, sir.
Okay, chalo. Okay, bye.
Thank you, sir.
Thank you.